The idea around encapsulation is that you have this essentially barrier between the internal implementation of your class and the various data attributes you store and the methods that work with it and the outside world. And in many languages, that's a very extreme barrier in the sense that there's no way to get around it. Python's a little different though. So let's look at an example of why this can potentially be a problem. So if we take a look at circle7.py, we have our circle class. It has the initialization method, a string representation method. I can modify the center and also retrieve it using the get center, get radius, get diameter methods, etc. Now, the interesting thing that has been added here is that I also want the capability to return the area, and of course the area is computed from the radius or diameter. And in this case, the decision has been made that the area is pre-computed. So perhaps we anticipate setting the size of the circle and maybe making repeated calls to get the area. And so to minimize redundant computation, the area will be pre-computed. So you notice that in the initialization method up here at the top, the area method is stored as a data attribute computed from the radius. And that means that anytime the radius is modified, I also need to update and recompute the new area that goes with that. And the same holds true with the diameter as well. And as long as that holds true, anytime you call the getArea method and self.area is returned, that will be the correct area that goes with the current size of the circle. So I'm going to go ahead and start Python and load this file. I get an instance of my circle, and it has a radius of 1. So if I call getArea, I get back that the area is just 3.14. Now, if I modify the radius and change that from 1 to 2, I call getArea again. You'll notice that the area that's being returned is now correct, and that's because when I called set radius, one of the things that the internal implementation of the set radius method does is update the pre-computed area that's stored within the class. But maybe you decide you're clever and you don't want to use the set radius method, and you realize that actually you can use the dot notation and make a modification to the radius like this. Now, the getRadius method still returns the proper value, but note what happens when I call the getArea method. The area is now wrong because while you modified the radius, you didn't make the corresponding change in the internally stored area. So now things are out of sync. And so because you've exploited this behavior of Python that you can still use the dot notation to access a data attribute, you've kind of screwed things up with this object. So what are your choices? Well, if I look at circle8.py, and we'll just look at the initialization method up here at the top, you'll notice now that I have self.double_x equals x, and so on. And the double underscore at the beginning has special meaning in the sense that it tells Python that you'd like this to be a private data attribute, not accessible from the outside using the dot notation. And you just need to remember that because you've changed it here, anytime in your later methods like getCenter, you need to be consistent, of course, and everywhere you need to use double_x, double_y, etc. So what's the significance of that and not being able to use the dot notation? Well, now I've started up Python using this alternate implementation of the circle class definition. I get an instance of my circle. And of course the area is correct, and I can of course still use set radius and make modifications, and the area is properly updated because I'm going through this method that knows if I'm changing the radius, I should also change the pre-computed area. But notice what happens when I try to use the dot notation, which was previously working and allowing me to modify the radius. It says circle instance has no attribute r, and that means that I can't modify the radius using that dot notation. Now you may be saying, well, of course he can't use the dot r because he changed them to dot double underscore r. Well, the other interesting thing is even if you knew that, it still says that you can't access that attribute. And again, that's because the double underscore at the beginning says this is a special attribute. You shouldn't allow anyone to use dot notation to access it. And so this is a way of protecting the user of your class from doing dumb things and trying to use the dot notation and screwing up the internal data representation that you've worked to set up for your class. Now, this holds in many languages and is foolproof, but in Python, it turns out that if you're super clever, you can actually still do some weird things and get this. So actually, if you use dot underscore the name of the class, circle with a capital C, and then double underscore R, you still can make a modification. So it's not that they've truly made it impossible to do something like this. They've just made it kind of super difficult, but a determined person can still use the dot notation if they're aware of this behavior and potentially get your class into an inconsistent state. But for your purposes, you should obviously not exploit this behavior. It's not good object-oriented programming style, but you should be aware that this is a possibility.